expression that's stretching that calf bone without a problem, but it doesn't actually allow our knee to bend because it's always just closing the gap on that length. We're also getting no stretch in our thigh bone as well. So let's set it up so that it's actually working on both bones to start with. I'm going to pick the calf bone, freeze the transform on it, and in this case what I'm going to do is go back and pick the nub bone on the end, open the dope sheet editor, find the 0 to X position, and this is the track with the expression controller on it. Right click on it, say copy, so I'm going to copy that controller, pick the calf bone, and on the zeroed out position X track I'm going to say paste, and I'm going to choose instance so that they actually both have one and the same expression running both. I can close this now. Anything I do to the expression on this nub bone will affect the expression on this one. So now when I actually change, you can see that indeed the knee is starting to bend, but in this case it's actually moving twice as fast as it should. Once again, to solve that, I'm going to change the expression. I want to put this whole piece in parentheses so that it calculates that first, and then divide it by 2 and evaluate again. Now it doesn't move twice as fast, but now the problem is it actually gets shorter as we lift the leg and the knee is not bending again. It is indeed stretching the way we like on the way out. So now we have to use an if statement. If statements in the expression editor are a little bit different than they are if you've used them in the Mac script. If C, T, F, and what that basically means, conditional value is T if C is true, else F. So we're going to evaluate C, and if indeed it's true, we're going to use the value of T, and if it's not, we're going to use the value of F, just separated by commas. So first off, I'm going to go and say if, open parentheses, close, and that's going to be for the entire if statement. So greater than 0. So what I'm going to do is I'm going to evaluate this and find out if it's greater than 0. If it is, I'm going to do the next piece here, and because the expression window is so small, I'm going to say enter and move it down to the next line. And if indeed it is greater than, I'm simply going to do the expression again, comma, if it's not greater than 0, be 0. Evaluate again, and now you can see as I lift the leg, the knee bends and the IK solver works as it normally would. But once the leg reaches that extended length, the leg starts to stretch to keep up. Now our last one little problem we have is that our knee is never allowed to go completely straight. To change that, we need to change the value of con a little bit more. We need to make this value a little bit larger. So we can actually experiment by just clicking this up a little bit and saying OK, and seeing where it works best. And that might have been just a little bit too much. Or you could have simply pulled this down to the point at which the leg started to go straight and check the value between the 2 points again to see exactly where you want to do it. Often I find the hit and miss method works perfectly well for me. I think 50.6 looks like it'll work really well. What's nice about this setup now is that foot rolls will even affect it if the leg suddenly gets too long or moved too far. If we lift the character and pull it forward, it'll start to stretch. we move the foot down too far, it stretches, keeps its length. Now obviously on a character like this, we don't want really stretchy legs, but this is great because sometimes you just want the character to reach that a little bit further without the foot coming off the ground, and you'll be able to get that now and cheat it without the ankle coming apart.